Here's another one. As you remember in the previous video, we took a look at the Sony CCU-TX7 Triax camera control unit, and we discussed what Triax is and roughly how it works, and then took apart the camera control unit or base station. This time we got one made by Panasonic. It's an AJ-BS901 Well, this is similar, but this time it's got the extra control panel part on it. Not sure if it's optional on this model. But this one is DVC Pro Digital Triax, so I guess it uses digital signaling, I guess. I found a service manual for this, but it seemed to only have part of it in there. Not really sure, I was a bit confused, but anyway, we're going to take this apart. I think it's in pretty bad shape. Again, I got two of them, and this one seemed to be the most beat up, so we'll take it apart. The I/O on the back, pretty similar to before, except only Triax connection. There's no other coax connection. Got the inputs, gen lock, the return video, and the prompter, so that's the same as before. And then the video outputs, less, although there's 3 encoded composite outputs, one picture output for which is output with the text overlay, waveform monitor output, and then again RGB or component, no YC by the look of it. Then there's SDI outputs. I'm not sure what the OP ones are, but yeah, 2 outputs, and then maybe they're optional, not sure. Optional waveform monitor, selector output, tally lights, a communications port in this round thing, the 2 audio outputs, and again it can be powered by the AC or DC 12 volt input. It's probably so you can have it in your OB truck or van. It says there it's 12 volts, 12 amps, wow. Or 220 to 240 volts, 170 watts. Interesting, it doesn't go from 100 volts input. And it says the output there is 100 volts, 850 milliamps. It says 85 watts the camera can draw. In addition to that big heavy thing, I also have 2 of the back. This is an AJ-CA901, so that goes with this. Unfortunately, I don't have any Triax cable, otherwise we'd try getting this going as a set. But we'll take this apart, see what's going on in there. I don't think I have any cameras that it can go with either. This one's still got its label, I'll keep that. The other one is missing the label. I don't know why, but that's the one we'll take apart. Because, yeah, without the label you don't really know what it is, but it appears to be the same thing. Anyway, let's take this apart. I believe it's possible, like the other one, to take the front off and access some additional controls and where the boards go, options, boards slide in and out. So let's see, those screws look like they would have been retained at some point, but now aren't. The bottom screws are missing. Oh yeah, look at that. Oh, I think that's lost its little hingy bits. Okay, some parts might be missing from this. This is very heavy, this thing. More than the Sony one, I think. And so that's the front panel part. I think that was an optional panel. Let's just see if that comes out. There's a ribbon cable connector there. I wonder what that's for. Guess could be programming of that chip there. Well, it looked like it could come out. Yeah, there you go. This is interesting, this has tape transport controls on it as well, so you can remotely control the DVC Pro deck, I guess it was. Yeah, DVC Pro. Those DVC Pro cameras that I had that we looked at a while back, they didn't have any provision for remote control or Triax back. I think this is for a newer or more advanced camera that can have those as an option. Wondering, should we try weighing this thing to see how heavy it is? Scale goes up to 15 kilograms. 9 kilograms. Okay, so that's why it feels pretty heavy. That's a lot of weight for this size box. I wonder if we need to take the handle off to get this cover off. Okay. Oh yeah, look at that. There's a plate in the top there so that the handle doesn't just bend the metalwork out. Oh, so we don't get access to much. There's fan grill. Well, there's a fan. The grill above it was very rusty. Now, you can see there the sliding mechanism that the front panel would have slid out with if that hadn't been disconnected. I have a feeling that this has got parts missing from it. That it might have been used as a parts unit, because you can see in there this rail is loose. So I'm wondering if one of the boards got taken out. Quite different to the Sony one, isn't it? These kind of D sub connectors. Everything's very well secured in there. Tried getting some of this out. Okay, so there's a spongy thing there. It's for retaining the boards. Quite heavy grade steel on these parts. Let's take the top piece off. We can look down and see the cards. Okay, is there more? Oh, that makes it difficult. There's screws going in towards the back. Oh, we can't even get to that because the fan is blocking. So we can just take the fan out. Good that they make the fan reasonably easily replaced. Just like that. Plugs in there. So that's good. Looks like there's a shielded box there. I think that's to do with the driving the Triax cable, because it seems to connect, the connector down there goes right through to that box. So I guess it's all one kind of sealed up unit for all the RF parts. Alright, card frame, shielding, there's that box. That can slide out. And all that part is some power supply unit. Ah, look at that. It can slide out though. You can see there are some locating pins and what looks like another D-sub type connector. So I reckon there's some screws on the back we can take out, probably just these two little ones. And then that unit will slide out. Is that possible? Doesn't feel like it. I feel like those have messed something else up. There's nothing on the bottom. It's just some bottom cover screws. So we'll get those out in anticipation. Now this unit here should slide out. I'm not sure what retains it. Still seems very well attached. There is some screws down there, but they're slightly too long for my screwdriver. Don't have anything longer. Okay. The bottom piece came off that easily. Okay, first we'll see if we can get this side off, whether that helps anything. Oh, if this side comes off, then we can access those screws. Oh, we're taking everything but what we want off. Guess we'll do both sides. Now, this thing, why doesn't this slide out? There's nothing holding it that I can see. I really don't understand. Maybe these side bits are holding it. I don't think so, because it should slide out, which shouldn't really need screws like this to come out. It has to slide out because it's got to undo that plug there. Maybe we'll just try prying it. Oh, that just bent the back plane. This thing is still very rigidly attached somehow. Oh, look. Do you think there's a plate there? Do you think that locks it in position? Oh, there is that screw. Maybe that's the one that's holding it in. Let's pull out some of these other boards to have a look at. Oh, look at that, we've got an Altera Flex chip. Very sparsely populated, isn't it? I guess that's the SDI Genim Altera Flex. And some special Panasonic ones. So it looks like there must be a more fancy version which has got this extra stuff fitted and then more outputs, I guess. Oh, it says 420p main. Where is that? Interlace. I guess you've got a progressive output version if you're fancy. There we go. So what was holding it then? Nothing was holding it. It was just that one screw. Wow, that's weird. That's so rigidly attached. Alright. Still pretty heavy. There must be a lot going on in that box there. Let's look at these other boards. So that one's got a special coax connector on it, which goes into the box. Oh, look, it says there's stuff written on there. It says BS-SDI, base station presumably. This is base station digital. More Genim. Didn't we see some of that in one of the Samsung TVs? There are more Altera chips. I'm not sure. I wonder if that's just a JTAG for programming it. Oh, those are glued onto another big chip underneath there. More good stuff. On the bottom, some bodge wires going around. So they must have altered, improved it or changed it. The last board. Another an Altera Apex. That one was Altera Flex. There's also a little voltage regulator thing. Some oscillator. It's BS audio. BS. Okay. So that plate we removed is just the grounding. Take the grounding pretty seriously on this thing. You've got these special strips so that the different panels properly contact each other. Okay, so that's now free, but it's not going to come out very easily because this backplane thingy is in the way. The design is quite different to the Sony one. Interesting to see the power supply, how does that differ? Okay, that should lift away. There's a ribbon cable to undo there. And then there's the SDI. So you can see there, another ribbon cable. Without wrecking the cables too much. Yeah, those the ones called OP1 and 2 were not connected to anything there, only the top two. So I guess if you'd get those extra chips soldered on so it does the 420p or whatever it said, then you'd have a different back plate and those would be connected up. Those other ones called OP, they are wired, but I guess it would depend what's connected to these. I think it was the BS decode board that wasn't fitted. We only had 3 boards. We had the SDI, digital and audio, but yeah, no decode board. Don't know what that means. Simple back panel. Alright, there's a power supply connector. Oh, and then there's connectors going back to the front. So now this module can come out. Oh yeah, so that's power into this box because yeah, the main power comes on that D sub connector off of there. Now, to work out what all this stuff does. Now we get to look inside the special box. Interesting that the wires from it go all the way to the back plane. It's like the design is a bit weird. Just want to tidy up some of this mess. Something really sticky has touched me now. Some kind of tape or foam or something's happened. Time to have a wash, I think. Then we'll get into this box. Alright, interesting that this extra connector thing exists here and the wires just come straight out. Probably, I guess, because they're made in different facilities and the wires have to be passed through a hole in this box, so they can't have a connector on it, so it has to be then soldered onto that little board, and then in the next stage this loom gets plugged into it. I wonder why they can't just crimp onto that, like crimp a connector onto the wires coming out, unless that little filtery looking thing there is important. Weird. They've cut a track there. Well, it's cut in the artwork, but then they've joined a wire. Oh, it's just... okay. So it makes that little black wire not joined to ground, but joined to the other side. Weird. Interesting. So they've used a wire on the bottom instead of cutting through the plane, even though it's on both sides. Interesting decision. So this box here, it's got the Triax connector out one end, here, and then at the other end it's got some D connectors with interesting back shells on them. And that there must be the camera power, I guess. You see there is a penetrator. See, those wires go into a hole, whereas that red one there is going onto a penetrator. And there's a ring around it, and it's loose. So there's the Triax connector. At this end we've got two D connectors, and this will be the RF signal. Let's undo these just to have a look at them. So going into that, it's 3 shielded wires, and one got ripped out. Some power looking stuff, and a bunch of just signal wires, and then this coax. I'm guessing those 3 are either, well, maybe those are the analog videos, like the returns and the prompter video, maybe, and everything else, the component stuff, goes in this RF. Okay, it's just a D9, and so is that, but it's the other gender. Well then, one thing left to do then, undo lots more screws, and we'll take a look in there. What exciting stuff hides in this box. Oh look, there's some little tiny screws there. Wonder if those need to come off now or later. I'll take these ones off for now and see whether the panel moves. Nope, we need to take these off. But how's it going to move when it's got these wires coming through it? Oh, okay, those ones are going to a heatsink. Okay. Wow, look at that. Okay, so that was double-sided thermal tape. Another Altera Flex, and yeah. Metal strips, so there's some kind of thing. Don't know what that is. There's some green thing there. Look at that, there's a real fancy coax connector there. At least this one's not all smashed in like the other one, the Sony one. So we can actually undo the screws. I don't know if that comes apart though. Oh, is it just plugged in? I think so. Let's see. Yeah, look at that. So it's just plugged into the back of that. That's a really nice connector. Is that? That's, wow. Okay, it's a long pin into that. Interesting. Doesn't feel like it's all the way in, but yeah, that's nice. And then this wire here was just a connector on the inside. Okay, so we should take this board out, have a look at it. It's all nicely sealed up. I was just looking, where does this go? Because we've got stuff coming in there, and that must all get multiplexed together, but then this one here, I guess that's the digital part of it, which then goes onto there, and then through various ICs and things. We'll have to undo the screws, won't we? From the D connectors. Oh, if it's zoomed out, won't be able to see much. That's good. Those ones can be undone with a standard nut driver. 5.5 millimeters. A lot of the D-sub thumb screw thingies are too small for that. Now, no. Yeah, but this isn't going to fit through the hole, is it? It does. Alright, what did we get out of that nice box? A board called BCRF with a bodge. With some Burr Brown ADS 8824Es. Guess we should look this stuff up, shouldn't we? So it's an analog to digital converter. Those two fellas there. 70 megasamples per second, 10 bits. Okay, obsolete. Some memory. I wonder what these are for. 70 megasamples. So it's not huge. And it says HD application HD TV video encoding. Okay, so perhaps those do the return video signals back to the camera. Yeah, I guess that makes sense. 70 megahertz sampling. That'll be fine for reasonable standard definition TV. And then there's these guys. It's a TX DAC 9708. I guess it's this. A TX DAC. 8-bit high performance digital to analog converters. It's 125 megasamples. So I guess that's making a the RF signal, I guess. Looks like RF amplifier type IC thing there. There must be some other type of DAC thing for this channel. Maybe that little thing there. Interesting, and then that will go into these. There must be some kind of combining device. Well, there's more those combining devices maybe, and then there's another little RF amplifier type thingy there. Then, oh look, there's more bodges. There must be another, what is that? Some kind of special thing. Is that just a relay? That looks like a relay, doesn't it? The shape, but it's got a heatsink and shielding, so I think that's an RF amplifier. Let's look that up. 1 gigahertz. Look at that. 1000 megahertz. 1 gigahertz. 18.5 decibels gain push-pull amplifier. Look at that thing. So the leggies of it, the legs must be under there, soldered down. And yeah, you can see it goes in there and to that point there. So then there's more business there. That must be the cap for blocking the DC. Oh, I see. So it will be that at one end, and yeah, a hybrid high amplifier module for CATV systems. Cable TV amplifier. Interesting. 24 volt. That will be useful for some kind of RF project. I have to give it to an RF person so they can do something useful with it. That was very exciting. That's quite interesting as well. You need a special tool to undo that nut around there. A thing that slides on and keys into it. Well, let's take a look inside the power supply. And then we'll take a look inside the camera end of this thingy. I suppose that would have another kind of RF amplifier thing in it because it has to drive the cable, because that's presumably driving the talk back, the return stuff onto the cable. And yeah, Triax cables, depending on the quality, which is usually the thickness of the cable, you can go quite a long way. The Sony one, I think it was something like 1.7 kilometers if you use the 14mm diameter cable, and something like 700 meters if you use the thinner cables. Whereas this Panasonic one, this digital system, I think they were a lot less. I think the maximum they could do was about 700 meters, but it's still a pretty long way, isn't it? Now, once you get into the optical systems, as we had a brief touch on, they can go as many kilometers as you want, as long as you got local power, 20 kilometers or more. And you can put repeaters in as well. Is that a 37, a DB? Not DB, a D37? It is 37. I don't know, maybe it's F. I can't remember the codes. DE9 for that size. B is the 25. Maybe it's C. C for that one, maybe? Don't know, can't remember those. Most people just say B for everything. A lot of people just say B for every shell size of those D subs, which is amusing. Can we get this thing out? How does it normally come out? Oh, another pretty busy unit. So we've got to get this other board out, or we've got to undo all these cables. That'll be easier. That's weird. Look at that. I've got like a screw terminal thing. I never see that inside like made in Japan products. They put distinct screw terminal things. That's so weird. Look how badly that's been terminated. Just crusty little strip the wire and bung it in there. Weird. That's really weird. This is also very interesting. Let's get a understanding of what's going on here. That just looks like an off-the-shelf power supply. So it's an AC 100 to 240 volt input, 12.5 amp output. So you reckon this is doing... Maybe this is doing what I suspected the Sony one might be doing, where it just converts the mains AC voltage into 12 volts and then just runs that into the input that it would be running from if you ran it from 12 volts without the AC. Because yeah, that main looking switch mode power supply there is just one of those off-the-shelf panel mounting open frame switch mode thingies. A very interesting heatsink. So it's pretty interesting then that they quoted this as a 220 volt input, not a full range input, when this power supply in it is a full range power supply. Look at that, it's just got a bunch of little screw terminals coming out of it. And that goes to not a connector. So the only way to undo that is to undo all these screws. Wow, you'd think they would have ordered it with a connector on it. Custom ordered it. I think there's no way that someone's bodged this in because the original one blew up, is there? It's too neat for that. Although you'd think they would have at least put a ferrule or crimp thing around these wires rather than just sort of twisting them and bunging them in. So it's just it is made in Japan, but it is just coastal, like a generic power supply. Pretty grunty. 12.5 amps, 12 volts. Decent caps. Nichicons. Bizarre. I wonder if it runs hotter when it's on a 100 volt input, so that's why they tell you not to do it. But then what would they use for their 100 volt ones? Maybe there's a better quality unit. Okay, so there's a little board there that the D37 goes to, and then that gets turned into these cables, which then go mostly onto this side. So we haven't actually seen much of a switch mode yet. I think it's all some fancy DC to DC converter. It's definitely something fancy going on in this thing, because there's a lot of stuff screwed onto there. And I guess a lot of these controls that were on there are just getting passed through from there over to here. Seems to be decoupled to ground. So what is this being screwed down? Oh, I think it's some kind of subplate that then is pushed onto all the other stuff. I guess. I think it's got some planar transformers in it. Must be something. There's an LM2577 switch mode controller of some sort. Simple switcher, step up. Okay, it's just a generic thing. It's not like a hardcore switch mode power supply controller. So then there was this. That must be just the input came off there. And then there's that. What did that go to? Oh, I think that was the mains AC thing. To there? Don't know about that. That just links to a fuse. Okay, that's probably from the DC part. Yeah, so the DC input connector is over here. Okay, yeah, I think it just goes from the either that supply or that one, depending on this chosen by this relay, comes onto here, plugs into there, goes through these filters, goes off to there to the front panel where there's a switch in the fuse for DC, I think it said. And yeah, because there was a separate switch for AC and DC, wasn't there? Nope, there was a switch for main and head power. Okay, so I guess that's head fuse then. 2 fuses. A 400 volt 1 amp fuse and a 250 volt 2.5 amp fuse. So that must be a fuse for the Triax cable, that 1 amp fuse. So maybe that's the output? This is so weird. Did the high voltage come out of this box on its separate cable, or was that all done through this D connector? Oh, I guess that's what those are then. From there to there. And through a filter, that must be the high voltage DC. Okay, in line with that fuse. Okay. Yeah. If you follow any of that, as I'm trying to make it up as I go along. Yeah, so that fuse on the front with 400 volts 1 amp will be in series with this, which is the high voltage output, which is filtered by those chokes. Okay. And that there is just the 12 volt input without any other goings on. Another screw here. Oh look, it's an integrated module. Okay, so there's a whole bunch of switch mode stuff here, which will be for creating the plus and minus voltages for the analog, lots of inductors to filter it. Oh yeah, so the stuff from the front panel comes on these shielded cables down to here, then links off again, and that's all decoupled by those thingies. Then you've got this with this like special I can't remember what that's called, graphite or something, infused thermal material, special stuff, and that is some kind of DC to DC converter module, which doesn't appear to have any part numbers listed. Oh, and that has its own fuse there, and it looks like there's 2 of them running in series, because the terminal there from one goes onto the opposing terminal, the other one. BS power. Cunning. It's done in a module. Sealed up in a module. 12 volt to whatever voltage, 100 and something volt converter. And then there's a bunch of other stuff. So that was that simple switcher adjustable version. And probably some other kind of switch mode controllery things over here. All good cosonic capacitors. Current shunts by the look of it there. More very interesting stuff. So the Panasonic one is quite interesting inside. There's some quite interesting, I'll just say interesting heaps of times. There's interesting stuff in that. I will just check. If we look at the The service manual I found for this didn't seem to be a service manual. What happened to it? Alright, so there's a service manual, but it's really weird because it's like at least half of it, so from this point onwards, so page 40 of 76, is just parts lists. So that's weird. And when you look at the schematics, it's going to prove me wrong now, isn't it? No. Or is it? Yeah, so it's got summary specifications, all that business, safety things. Then it's got programming the Altera chips to update those. And then it's got some adjustments. But it only tells you about the BS audio board. See? Block diagrams. Audio block diagram. That's the only one they give you. Then it's got schematics. And again, the only schematic they give you is the audio board and the power board. So none of the other boards are featured. But at least we can have a look at the power stuff. Exploded views. Now, where was the power stuff? 2 modules somewhere. That's what I want to see. Maybe that's those guys. So they've got a trim. Yeah, so each one's got a 5 amp fuse. You can see on the board. Comes off this 12 volt rail. Relay with both poles in parallel. Okay, so that switches it on and off, that relay there, which is that relay that's on the same board. And then we power into these guys. It doesn't tell you what comes out, does it? It's just got plus and minus out, sense outputs, and a trim. You've got a 20k and a 330k across that. Maybe it's a variable power supply. Maybe this, can we look up these numbers? And then that's the high voltage out, 100 volts out. So 2 units in series, it must be 50 volts each. Maybe they're normally 48 volt converters for like telecom stuff, and they can trim them higher to 50 volts and put 2 in series and you get 100 volts. Alright, that's interesting. Let's have a look. 0N0BG doesn't come up with anything. The other one's VI-J04-CY. Equally non-descriptive. Seems like a Vi-core. What's a power box? Okay, there are data sheets for that. Wow, there aren't data sheets for it, but there's some information that it exists. Alright, here we go. This is the guy. The doofy. So it is Vi-core. Yeah, so that part number VI. 25 to 100 volt PC mounting. Okay, so it'll be a 3, I guess. J4. I don't know what part of the part number that's in. VIJ, then A4. A4. Oh, so it's actually a 72 volt unit. And then CY, 25 degrees, 50 watts. So it's a 72 volt unit. J4. Just from that J4. VIJ4-CY. So C and D is CY, 50 volts. 50 watts. The input voltage. Oh, hang on a minute. I read that wrong, did I? It says AB there, but this one just says J4. I don't know if that's A or B. J4. 4. Oh, that makes more sense. Output voltage 48 volts. The input voltage would be 12 volts. 0. I guess that means not there. J04. Yeah, so it's a 48 volt, 50 watt with a trim and sense inputs. Nice module. Alright, that's the power supply, and it's surprising and interesting and unexpected. It's like the solution where you just give up and go, oh, we'll just buy a module, we can't be bothered making our own converter, we'll just buy one. Alright, we're going to take this thing apart and see what it has to offer. That probably wasn't a very good idea to take that off yet, because it's just a ribbon cable in there that we can't undo. So this is the part which goes on the back of the camera to give it the Triax capability. Panasonic digital Triax. Wow, a lot of stuff in there too. So this won't have so much fancy power supply stuff. No, it will. It will, because it's got to convert down from the 100 volts to 12 volts. 12 volts, so what is that? It's another one of those modules, isn't it? Hey, there's the heatsink for it, and you can see it right there. So that must be a 100 volt to something volt adapter. Exciting. And those boxes there must have the good RF stuff. Look, you can see another one of those good cables there. So that's the thing that simulates a battery. Guess goes where the battery mount would be. It mounts where a battery would mount on the camera. Which would just be, it's just a generic module on there. What's that next thing to come off? Wow, long screw. Does anything come off on the side? Yeah. Okay, so there's a normal 12 volt input, and then there's the return output and the prompter output. Nice high quality BNC connectors too. Proper 75 ohm ones. So that's the program out, so that's audio feedback from the base station. And the intercom, which goes back to the base station. And that's a DC output. Interesting. So that's the powering accessories on the camera from the power that comes over the Triax. Rated up to 500 milliamps. Not particularly grunty, 6 watts. More connectors. Some power business going on there. Okay. I don't know what that stuff undoes. It's an inner sub-assembly, I guess. Now we've got a coax going around there. One coming across here. Let's pull these things out and take a look at them. Cam digital. Lots of stuff on it. All Panasonic chips. And then we've got a cam power. Okay, so it's a power supply that reduces various voltages for running the camera bits and pieces. Then cam RF. Okay, so it's got 3 paths by the look of it. Some shielded bits on the bottom. You can find those RF power amp things though. Now, this last bit. Oh look, that's what comes off. Okay. So now by taking this off, okay, so that's the battery mount. Then if we undo these screws here, we can release that ribbon cable. That's nice. Nice and interchangeable there. A nice securing thing, camera interface. Okay, so that backplane is very self-contained. There's no other than power, nothing else goes onto it. Something called Intel System Usage Report is using up 50% of my CPU right now. What's that all about? System Usage Report. So that's spying by sending them a whole bunch of information, is it? And why does it use so much CPU power? That's high-end CPU. i9-13th. Just killed it. Guess you should not put the Intel driver updating assistant thing on your computer. thought that was going to be useful, but all it does is keep nagging me to update the Bluetooth driver when I don't even use the Bluetooth. Okay, so there's a circuit breaker there. 5 amps. Yeah, it doesn't help much because there's wires underneath it. Alright, so we can see there's a swiveling part that the Triax connector goes to. Sort of cap thing has been ripped off at some point. Okay, so there's a strap for the ground here, and then there's the coax, and it's got a little bit of a loop in there so that as you swivel the housing around, it will follow nicely without stressing the cable too much. Okay, now we can see this stuff better. Try and get this thing out. Another block there, which is interesting, going onto the top, like an additional heatsink thing. Okay, we'll try and unplug that. There we go. Right, so here's another one of those. Interesting that they put that tape over that special stuff. Guess it was important to shield everything properly. There's a bodge there, a FET sub. It's sleeved the legs of that resistor so it can span over there. Interesting, it says 100 volts in, 100 volts out. And they bypassed that, put a break in the track there. They put a bit of stuff over it when exposing the board. 100 volts. And then it becomes 12 volts on this side. Must be the trim resistors there. There's a little cap on it. See, that's 25 volt 220 mic cap there. And then there's the little RF separating device. So it's got the digital, which goes onto one of them, which is the one that came from that longer wire, from that digital board. And then there's the other one called RF, which came from that RF board with the bits and pieces in there, those 3 channels. So that there is the other end of this board, which has got those 3 channel thingies on it. And then the other one, which is this one, is presumably the other end of this one, which was the BS digital with its little RF connector. Yeah, I guess it's a different type of amplifier on this. It'll be under that copper plate there. And then Triax connector. Yeah, there's another little heatsink thingy there. There's a heat transferring pad and then an aluminium block. Oh, maybe it's, I don't know, it isn't really paste under there. Okay, those little rounding things are screwed down, screwed on, as were the ones in the base station. It's all good quality stuff. Pity it's all obsolete and just being thrown away now. It's seen a lot of use though, it's pretty beat up as you saw. Okay, so it's the swiveling part. Oh, look at all the little bits and pieces to make that work. With grease on them to hold it tight under tension. Oh, and it's like a Teflon type stuff there for it to slip against. And you see there, the cable was folded in that arrangement like that, so that as it, whichever way it was, like that, well, in a way that meant it can slide around nicely without stressing the coax. Triax. I guess it's, no, it's coax at this point, because yeah, the third one is the screen. This is again just a coaxial cable. Yeah, same deal as the other with that really long pin in the center. Is that sure? Or was that a P or something on the beginning? I don't know. Looks like an F with an O, 1051. And is that a complementary? Yeah, so you do need a... Oh, look at that, they join together. Yeah, male to female cable. So we could have tried it without a cable if we'd just arranged it so we could push these things up to each other. Oh well. There you go. That's a look inside the Panasonic digital Triax base station and the accompanying Triax back for some particular model, which I'm not sure what it is, of Panasonic video camera. And a discussion about the various parts. And it's interesting to see how they differed from the Sony one that we took a look at on the previous video. Now this thing is getting scrapped, sorry. But the metals will go to recycling and might be able to find a use for some of those other bits and pieces. So stay tuned for the next video. Can't guarantee it's going to be soon since work and other things are happening a lot. But we might go back to VCRs, I think. Back to VCRs. Continue with VCRs. We'll see what happens. There is a bunch of other equipment to take apart and investigate. Some studio camera flash equipment. And some other things. So look forward to that. Might be a couple of weeks though. And that's it for now.